Now we come to the sum of n terms of special series. This is class 11. We are talking about sequences and series. So if we want to add this 1 plus 2 plus 3 dot 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 n, we have already seen in section 9.4 that the summation of 1 to n is n plus 1 by 2. How about 1 square plus 2 square, that is the square sum of squares of first n natural number, or 1 cube plus 2 cube till n cube, that is the sum of cubes of first n natural number. So when we want to find out this, Sn is equal to 1 plus 2 plus 3. This is, we already know, n plus 1 by 2. So if you want to find out, just consider an identity. K cube minus k minus 1 whole cube is this. Okay, if you find it out, if you compute it, this is going to be the same, 3k square minus 3k plus 1. Just place k equal to 1, 2 and all. So this is 1 cube minus 0 cube, 2 cube minus 1 cube, like this. These are all the expressions. So ultimately you get n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. So what you get here is this one is 0, n cube. This you already know, n plus 1 by 2. So how you are going to write it? This by sigma. This is sigma k is equal to 1 to n. How about this 3 sigma k is equal to 1 to n k square? This we have to find out. Take all these values on the left hand side. So what you get here? 1 plus 2 plus 3 plus n. You already know this is n plus 1 by 2. This can easily be written as n plus 1 by 2. How about this k square? You have to find this. This is 1 by 3. Take 3 on the denominator. N cube plus 3n n plus 1 by 2 minus n. Just rearrange it. You will get n plus 1 to n plus 1 by 6. This is very important. This is sigma k square or n square. Summation of n square, 1 to n square. How about Sn is equal to n cube plus 2 cube till n cube? Just consider this identity k plus 1 whole to the power 4 minus k to the power 4. You get 4k cube, 6k square, 4k plus 1. So if k is equal to 1, 2, 3 till n, what we get? 2 to the power 4 minus 1 to the power 4, 3 to the power 4 minus 2 to the power 4, like this. So ultimately you get n minus 1 to the power 4 minus n, this one, n to the power 4 minus n minus 1 to the power 4. So just rearrange it, you get this. Now you can add both sides. This one 1 1, this one, this whole and this whole. Just add. So you get n plus 1 to the power 4 minus 1 to the power 4 is this. 4 into sigma n cube, 6 into sigma n square, 4 into sigma n and n. What you get here is, for sigma cube, this you have to find out. This we have already found out. This already we know. So this sigma k is n plus 1 by 2. Sigma k square we have just found out as n plus 1 to n plus 1 by 6. This we are willing to find out. So this can be viewed as whole. We are just rearranging. So when we rearrange, you get n square, n plus 1 by 2. 4. This is n plus 1 by 2 whole square. So let us find the sum of n terms of this series. So how we are going to find out? Sn is this. This you write as it is. an minus 1 and an. This you have to add. Now Sn is, just leave this space and 11, just start from here. 5, 11 and just below an minus 1 should come, so that we are left with this and this. Okay. Now subtract these two. Sn minus n, Sn is what? 0. So you get 5. 11 minus 5 is 6. 19 minus 11 is 8, like this. And this everything will be subtracted, only an will remain, an. So an you can take it on the other side. This is nothing but n square plus 3n plus 1. Now this is okay. This you have just rearranged. But this is actually the summation n plus 1 to n plus 1 by 2. So you have just summed it up. And now n square plus 3n plus 1, you can find out the Sn using sigma of an or ak from k is equal to 1 to n. This is k square plus 3k plus 1. So sigma k square, 3 sigma k and 1. This sigma k square is n plus 1 to n plus 1 by 6. The sigma k is n plus 1 by 2. And this n is like n. So this is the answer. Find the sum of n terms of the series whose nth term is this. So an is given as n plus 3. So n square plus 3n. This is your nth term. So you have to find the sum of this nth term. You can just take sigma. So sigma of ak, that is this one, the sigma of k square plus 3 sigma of k. and k square is n plus 1 to n plus 1 by 6. Sigma k is n plus 1 by 2, and this is the answer. Let us take some miscellaneous example. P, Q, R and S, these are terms of AP. They are in GP. So these are terms in AP. So AP is nothing but A plus P minus 1 into D. AQ, AR, AS is A plus S minus 1 into D. This by definition we have written. Now these are in GP also. So if you take AQ, this one by AP, AR by AQ, AS by AR, you can get these values like this. So you can use this component dividend window, and you subtract these two, Q minus R by P minus S. You subtract these two, R minus S by Q minus R. So ultimately you get, if you equate these two, because they are equal, if you equate Q minus R by P minus Q equal to R minus S by Q minus R, you find out that these three are in GP. ABC are in GP. A to the power 1 by X plus is equal to B to the power 1 by Y, and C is equal to 1 by Z. So you have to prove X, Y, Z are in AP. If they are equal, let us assume it to be some K. So A will be K to the power X, B will be K to the power Y, and C will be K to the power Z. Since ABC, this is given that they are in GP, so B square is going to be AC. B square is equal to AC. So in 1 and 2, you get K to the power 2Y, that is K to the power 2Y. Just place it here. In place of B, you place KY. In place of this KX, these places, you just have to place the value of B and A and C. You get K to the power 2Y equal to K to the power X plus Z. So 2Y is equal to X plus Z. Whenever this is the case, X, Y, Z are in AP. Now next is A, B, C, D, P are different real numbers such that this is the equation. Then show that A, B, C, D are in GP. See, if this is less than equal to 0, given this is given, this LHS left hand side, if you rearrange it, this is nothing but AP minus B whole square, this is BP minus C whole square, this is CP minus D whole square. And if this is just since the sum of square of real number, this cannot be non-negative. This has also, or this also have to be positive always. This cannot be negative. So if you add these two and say it is equal to 0, then this has to be 0, this has to be 0, this has to be 0, because they cannot be negative. And with this you get B by A, C by B, D by C equal to P. So you have all these having a common ratio as P. So A, B, C, D are in GP. This is PQR in GP, and the equation this one and this one have common root. So if you find out the root of this, you can use it as a root of this. So PQR in GP, first of all, let us solve this. When we solve this, this is Shri Dhanacharya formula, minus 2q plus minus under root 4q square minus 4rp by 2p, b square minus 4ac by 2a. Now PQR are in GP, so you can use q square as PR. Q square is PR because they are in GP. So x is equal to, when you solve it, x is equal to minus q by p. But since these two have common roots, this root will apply to this also. So we can place minus q by p in this equation. We place in this equation and we get this as some intermediate equation. And when we divide by pq square and also place q square equal to pq, we find this e by q is equal to d by p plus f by r. That means this, they are in AP. So let us summarize that by a sequence. What are we meaning? This is the arrangement of number in definite order according to certain rule. This is sequence. So we define a sequence like a function whose domain is going to be a natural number, or say some subset of this type. So sequence containing a finite number of terms, we call it as a finite sequence. Otherwise, if it is not finite, we call it as an infinite. So A1, A2, A3, these all, if we add them, then this A1, A2, A3, this sequence becomes the series. This becomes the series. So a series is called a finite series if it has got finite number of terms. And an arithmetic progression AB, actually it is a sequence in which the terms are going to increase or they are going to decrease regularly by some constant. This is called the common difference. Actually this constant is called the common difference. We denote the first term AP by A, the common difference by D, and the last term by N. And the general term of the nth term of AP is given by N is equal to A plus N minus 1 into D. The sum of first n terms is given by Sn is equal to n by 2, 2a plus n minus 1 into D, that is n by 2 a into n. The arithmetic mean of any two numbers A and B is going to be this plus this by 2, that is A plus B by 2. So A, capital A and B, they are in GP, AP, arithmetic progression. When we talk about GP, a sequence is said to be in GP or geometric progression if the ratio of any term to its preceding term, if these are the terms, then ratio of this with this are going to give you some value constant, that is the common ratio. We denote the first term of GP by A, its common ratio by R. The general or the nth term of GP is going to give you A n will be equal to A r to the power n minus 1. And this Sn of first n terms of GP is given by A r to the power n minus 1 and r minus 1 divided by r minus 1. You can write, otherwise A 1 minus r to the power n by 1 minus r. So the GM or geometric mean of any these two positive numbers in B, it is given by under root AB, and this sequence AGP is in GP. So this is all about sequence and series. Thank you so much. Take care of yourself.